Co-author is Dr. Richard S. Bishop. He's sitting right up in the front. And among many things, Dick is a fan of giant fields, and we seem to have a lot of fun with that. But some of you may realize that Dick's mother, Margaret Stearns Bishop, was the chairman of the University of Houston for many years. So quite a distinguished connection, I think. And thank you, Juan Carlos. That was really great. So let's talk about imaging. We're going to build on the power of imaging, and we're going to talk about something that in the oil and gas business is about the most exciting thing you can talk about, and that's the discovery of a giant oil and gas field. Our talk tonight is focused on lessons from giant fields and constantly coming back to global database. And our question we're going to keep asking ourselves is, how can you build a strategy from learning about the giant fields to help us find more? So, with that in mind, how many people here saw the earlier version of this talk at GeoGulf in April? A few people? Okay, great, a few. So please don't answer this next question. For the rest of you, what is the biggest giant field in the Gulf of Mexico? Anybody know? Is it in Mexico? The biggest field in the Gulf of Mexico is Cantarell. And the reason Dick and I like to start with this at the talk is we who focus on the US Gulf of Mexico and who work it, and many of the students here will work it as well, we want to encourage everybody to elevate our thinking and to think holistically about the full basin. So happy silver anniversary to the sheriff lecture. And this is gift confetti. It's much easier to clean up than real confetti. And I want to give a shout out to David Moe and Dwayne Pierce, who are here. So 25 years ago, these folks were heading up the University of Houston Alumni Association. And they came to me. At that time, Dave and I were good friends, and I happened to be president of HGS. And they had this idea for starting the sheriff lecture. And here we are 25 years later. Hundreds of students, like congratulations to all the students today for these great posters. There have been hundreds, maybe even 1,000 students who have presented, and 25 great lectures. So let's take a word from Bob Sheriff himself. If you read in the lower left there, I'd like everybody to take a moment and read that. It's in the introduction to his encyclopedia that Rob Stewart mentioned. And I'd like to encourage all the students to participate in one of the ways to give back and to improve your own skills is to be part of your local and professional societies like APG and SEG. And the second thing is, I was looking at U of H's webpage. U of H is recognized worldwide as a leader in energy, health, research, law, business, and environmental education. Notice the word energy. How fitting for a university, a tier 1 university in the energy capital of the world. And I'd like to think that the sheriff lectures have had a lot to do with continuing that tradition. So why do we study giant oil and gas fields? Well, there are a lot of reasons. You can see them here. But I think that for me, I'm going to quote a combination that's rarely quoted. I'm going to quote a bank robber and an Italian economist in my next slide. So when Willie Sutton, the famous bank robber, was asked, why do you rob banks? Well, you can read his quote, that's where the money is. And Vilfredo Pareto, some of us have heard of the Pareto 80-20 rule, also known as the law of the vital few. He commented that 80% of just about anything is controlled by 20% of something. And so the 80-20 rule simply applied to oil and gas fields. The big fields really matter. So if you look at the purple circles, all 79 purple circles on this chart, they represent giant oil fields and gas fields that are 500 million barrels of oil equivalent or larger. The 8 larger yellow circles represent supergiants. They're 2 billion barrels of oil equivalent or larger. Now there are other ways to define giants. Some people call giants 100 million barrels, but Dick and I are choosing to use the larger global scale, 500 million barrels. And when you look at those 79 fields, they make up, if you look at the US, Mexico, onshore, offshore, 210 billion barrels oil equivalent in all the basins. That's more than half come from 79 fields. So there's why we're talking about the 80-20 rule. And 8 of those fields have 26%. So the reserves are huge. And looking around this room, I think those reserves are pessimistic because I see a lot of young professionals that are ready to go find some oil and gas. How do we study giant fields? Well, we have publications like this from APG. Every decade, we do case studies. Everybody who studies oil and gas knows that analogs are critical. Prospectors, discoverers, and we have case studies decade by decade. Now, we've learned a few things in the most recent decade I'll talk about in a minute, but the decade I'm most interested in is the 2020 to 2030, because a lot of the discoveries that are going to happen by people in this room. So the last publication that I just held up has an ArcGIS database. We want to give a shout out to John Dolson, and we can share that data set with individuals who are interested. What we have learned in this last decade is things have changed dramatically. We're seeing more stratigraphic combination traps than ever before. 3D seismic is imaging, and that's what's making seeing these stratigraphic traps possible. We're pushing the envelope on paradigms. We're finding oil and gas fields over oceanic crust that used to be thought too thermally cold to mature. We're finding oil at greater depths than ever before, and many of the fields have hydrodynamic surprises. And tonight we just talk about conventional. So here are the questions we want to answer in the next few minutes. What limits giant field sizes? Where are the giants? And what roles does the dynamics of technology and integration play in their discovery? And ultimately, what we're trying to get to, and what I think is important for everybody in the industry, is to devise strategies for what you want to find. And if you want to find something big, we need to define strategies to find giants. To do this, we have a methodology. These are the 7 habits of highly creative energy geoscientists written up. I brought a library with me tonight in one of the APG special memoirs publications for the APG Bulletin. These include technology, source, reservoir traps, analogs, economics, and how we put them together in a creative way. So in the next series of slides, we're going to address these elements that are part of the toolkit. I want to give recognition to Richard Sears, who spoke to the HGS on September 11th. He talked about waves of exploration. And in the technological development, you can see the progression of waves of exploration. And of course, many of us have lived through multiple of these waves. And the big question is, what's wave number 6? We don't know yet. As we look at how the geophysics has driven these waves of discovery, and the clusters on the bottom, we've broken them out into 6 major geophysical developments. They have driven the discovery of giant fields and supergiant fields. The last supergiant field, Cantarell, was found in 1980. And so the question is there any more supergiant fields in the Gulf Coast? I'm an optimist. I'd like to believe yes. So how are we going to find it? And as the price varies, giants, through time, you can see some of the high prices. Giants create incredible wealth that is then put back by industry for the further exploration. So giants play a key role We're going to step through a couple of technological advances, maps. Think of them as time slices. So as we go through the early days, you can see the progress bar in the lower left. The big fields were found onshore. Then we got close to the coast. Then, after World War II, we stuck our toe in the water. And so you can see the HGS logo in the upper right. In the mid-century, last century for HGS, we were looking out into Galveston Bay at this incredible offshore frontier. And then, with advances in offshore seismic acquisition, DHI, we continued to progress. 3D seismic took over. We began to unravel the mysteries of subsalt. We marched out into greater depths, so the giants were getting into deeper and deeper water. So here are some time slices. So one coast just showed us some great images. So on the upper left is subsalt, a big high. And the seismic in 1997, the quality offshore was good enough to find a big high. But as we progressed through time, we got much better resolution. And I put in approximately when the sheriff lecture started in 1999. Look at these in continuing improvements. Much greater resolution on the maps and integration with the wells. Compare the upper left to the lower right. This is in just about 20 years. So of course, we can't wait to see what happens in the future. Let's look at the profiles. So here's the seismic at around the time of the first sheriff lecture, and you can see a high below the salt, starting to get better. Look at the lower right with OBN, ocean bottom nodes, full waveform inversion. Look at the internal faults within the red box. Much more than just a high, incredible definition. So, you know when you go to the eye doctor and the eye doctor says, which is better, the upper left or the lower right? I say the lower right yet to come. I can't imagine how good the seismic is going to be. And our engineering friends have been a huge help throughout this journey by finding the technology to take us into deeper water. They're opening new realms for exploration. And these realms are taking us onto transitional or oceanic crust. Remember one of the paradigms? And here's Tiber Field in Keithley Canyon, a little red arrow pointing to it. It is one of the deepest, 3,600 feet, one of the deepest offshore giant fields. We're finding oil giants not only at 5,000 meters, there are 13 out of the 49 global giants at that depth, but when you look around the world, there are 9 giants greater than 7,500 meters below the mudline, 6 of them in the Gulf of Mexico, including Tiber, which is the deepest oil field in the world, right here in the Gulf of Mexico. So as we work our way through the toolkit, let's talk a little bit about source, reservoir, and seal. So the purple and the green at the bottom are the source rocks, close to the basement, deeply buried by Cenozoic sediments, rapid infill, salt, which forms traps and breaks traps and is mobile through time and has a thermal effect conducting heat, buried by many reservoirs in what is a generally leaky basin. That's a quick profile of the Gulf of Mexico. As we look at the source rocks, you can see we have incredible Jurassic source rocks, multiple Cretaceous source rocks, several oceanic, anoxic oceanic events, and we have Cenozoic source rocks as well. So there's an abundant and prolific oil charge underpinning the giant fields. When we look at the reservoirs, all giants, they're giants of all ages, but most of the giants are in the Miocene or the Cretaceous, and most of the volumes are in the Miocene or the Cretaceous. And the Cretaceous has the largest size fields on average, and of all 8 supergiants, 8 of them are Cretaceous. Interesting. So why is that? let's see what we can do as geologists. Geologists can always make a story, right? So let's remember back to this diagram. The source rock's deeply buried, close to basement, the many reservoirs on top, and the hydrocarbons striving to get out of the basin through the many seals to escape and to the surface. So it begins with the source low in the column. The Cretaceous supergiants are associated with basement-related structures, and then the seals are regional sags and events that are transgressive that create big top seals. And as we look at what limits the giant fields, what I believe we're seeing is that the limits of why the fields spill, why the giants only get so big and not larger, is that they're filled to spill, and the better seismic imaging is helping us to see that. And of course, we've had Allen fault plane maps and things like that to help us understand the leakage. Another thing about the giants and the supergiant fields is they're mostly oil or oil and gas. They're 80% oil and 80% oil and gas. Remember the Pareto rule, 80-20? And all of the supergiants are oil or oil and gas. There are no gas supergiants. That's interesting. That's because we see a lot of seismic chimneys and the oil is retained preferentially to the gas, which leaks. And this is not unique to the Gulf of Mexico. We see this in offshore Borneo, where large and giant fields preferentially retain oil and leak gas. So we have a leaky basin in which traps are controlled, the size of the field, and guess what? We have the tools, which is seismic imaging, to define those traps. So when we look at giant fields and their structural style, if you look at the growth faults or the salt-related traps, we call that simple detachment. Look at the purple circles on this field. There are no yellow circles. There are no supergiant fields that are the detached structural style. The numbers for the detached structural style, like we're showing in the upper left, are basically max out at about 1 billion barrels, which is not bad. But if you're looking to find a supergiant, you're probably not going to find it in the detached types of structures. And when we compare it to the global database from Africa and Brazil, we see that the giants max out at about 1 billion barrels, and sometimes the giant fields coalesce into field complexes, but they're individual fields, and there seems to be a limitation by that trap style. So let's look at the supergiants. Back to Mexico. So all of the supergiants are Cretaceous age reservoirs, and all are associated in some fashion with basement, either domes, arches, or platforms. So our star performer in the northern Gulf of Mexico, East Texas supergiant, is on the Sabine Arch. It's on the purple high. These pink highs are basement-related highs. And so this East Texas trap is a truncation next to a basement high. Poza Rica and the Golden Lane are reefs and carbonate buildups, Cretaceous carbonate buildups sitting on basement highs, and Cantarell Field and the fields around it are duplexes and thrusts bouncing off a basement high. So let's talk a little bit about the Cretaceous. The Gulf of Mexico is full of surprises. As recently as about 13 years ago, the prognosis for the Cretaceous was limited. But Peter Mullen pointed out in his talk in October 16th that a lot of recent work at these fields, Apache, number 1, Highlander, Silverback, Galapagos Deep, Davy Jones, we're starting to build a new case for potential for Cretaceous sands, busting the old poor reservoir quality and poor carbonate marl quality. And so there may yet be a few new surprises in the northern Gulf of Mexico, possibly associated with the eastern Gulf of Mexico. And here is a cross-section from John Snedden showing Cretaceous sands existing in some of the more recent wells. And when Dick and I first did this, we saw this ion line great regional line, and of course we see the big thick Miocene package. And we were looking down here at the Cretaceous because a lot of the big discoveries, giants and supergiants, we're seeing globally in fans associated with basement highs or just plain distal fans. But this is pretty deep. This stuff is pretty deep and possibly not economic, but this is what has some folks who have worked the Gulf of Mexico have called winky blinkies. But if we look at the Florida escarpment and just kind of zoom in a little bit, and in this cartoon format, these are the Aptian and Albian carbonates, which are known to be major reef formers in Mexico. We see shelf edge reefs, we see reefs and buildups within the platform, and then we see the possibility for outboard carbonates. If we look at this map showing the pink highs and the yellow supergiant fields, we're going to fade away, but for a minute, just keep an eye on where these yellow supergiants are and where some of these pink highs are, and we're going to fade away. Oops, there we go. We're fading away to the carbonate margin, and some of these pink highs are peripheral to the carbonate margin edge that wraps all the way around, and in Mexico where it occurs in various platforms. And so Peter Mullen showed an example of an offshore, out from the platform, what looks to be a buildup, yet from the depth information we have on this well, it doesn't look like it tags what could be carbonates on basement. This is an example of perhaps some things to do in the eastern Gulf of Mexico. And there are a lot of examples of where basement highs have reefs on them. This one is from Poza Rica and Golden Lane, and in fact, this very slide was seismic interpreted by Bob Sheriff. How cool is that? And look at the quality of the seismic they had back then in the 1980s. There are other examples of big buildups on basement highs, like the one in the Oligocene Miocene in Southeast Asia. Different age, but same concept. And similarly, in offshore Egypt, look at the quality of the seismic above and below. This is well deep, about 160 kilometers offshore from the shelf margin, and there is a major carbonate buildup out in front of the shelf. And when we go back to the global setting, back to the giant fields globally to check, do a reality check for the giant fields of the Gulf Coast, we're seeing globally more stratigraphic traps found, more clastics, turbidites, and a lot of carbonate reefs and buildups, many of them Cretaceous. So we want to, one of our super basic thinking toolkits is economics. So we've talked about the geological elements, we've talked about technology. So if you look at a field like Mars in the Gulf of Mexico, it has a very thick vertical bar and a very concentrated area. If you're going to find a giant, that is a very concentrated resource. Similarly, Zor, which we just talked about, carbonate buildups tend to be very tall and very thick, that giving us the chance to find very thick columns over very large areas. And so some other giant fields are big areas and they're widely spread out. So one of the things as we search for giants is we may want to factor in the economics for stacking up big, thick columns. So we're about to wrap it up. So predicting the future, everybody knows is tough, but I always think of it in three ways. There's three ways to predict the future. Let's extend the trends of things that are already partly seen, and we can list a few of them here. There will always be things unseen, and then there are just fundamental demographics. So some of the things that we're extending that we're already seeing is stratigraphic and combination traps are being found in greater frequency than ever before. Seismic imaging is helping. We're finding oil at greater depths. We can push the limits on oceanic crust, and we're going to have hydrodynamic surprises. Perhaps There is some potential in the eastern Gulf of Mexico for not only sands, but carbonates. And the demographics, I think, that are going to control the discoveries of the Gulf Coast are symbolized here in this room. We have a great workforce in the industry, represented by the Houston Geological Society. We have great universities, like the University of Houston here tonight. And as we combine the intellect, technology, and capital within the crossroads of a major infrastructure, I predict there are going to be many great discoveries yet to happen in the Gulf of Mexico. So we need to make a strategy to make it happen. So to answer our three goals for the talk, what limits the giant fields? Trap limits the size of the giants, evidenced by leaky basin, faults, escaping gas, and we can tie the spill points from very good seismic. So how do we put this into a strategy? We need to focus for stratigraphic and combination traps and do deliberate searches. What have we learned from the history of giants and supergiants? Well, most are Cretaceous and Miocene. Detached giant fields are great, but they're limited. And if you want to find a supergiant, you might want to try to look for Cretaceous or Mesozoic aged reservoirs close to the basement, close to the source rocks, onshore or offshore. And what role does technology play in discovering these things? So devising a strategy that might include seismic imaging and drilling technology that opens new realms of access. Be fearless in extending some paradigms, and there will be new seismic developments yet to come. Henry Penningill tells me he can't wait for subsalt AVO to happen. Focus imaging technology on finding more stratigraphic traps in basement. So with that, we would like to thank many reviewers and muses who have shared their thoughts with us, some of them in this room, and we would like to dedicate the rallying cry to looking for giants to big thinkers like Michelle T. Halbody and Bob Sheriff. And the final slide, we want to remember, think holistically, think at an elevated perspective, and think big.